A very short demo about circuit in series. So I have three loads. They have about the same resistance, but not quite. So now you see that they kind of have to share the voltage, right? So that means they don't get the whole voltage available from the power supply. So if I measure the voltage across the power supply, you see it's 4.13 volts, and that the voltage drop across, if you add all the voltage drop, you should get 4 point something. So you see here you have 1 volt, this one has 1.5 volt. Okay, so that means there is more resistance here, takes more voltage drop, and here you have about 1. So this one and that one have the same resistance. They have 1 volt across, 1.14. Here it's about the same, 1.1, and here it has 1.5, and it will add up to the power supply. So you see the voltage drops will add up. If you are measuring the current should be the same. Doesn't matter where you measure it. So the problem to have loads in circuit is that if one load dies, so I'm gonna unscrew this one, all of them goes off, right? So it's not very convenient. They don't get enough energy, and if one dies, all of them dies. So instead, we build what it's called the circuit in parallel. Okay, so it's very simple. So this one is happy now. It's gonna get all the energy it needs. So the voltage across here will be the same as the voltage across the power supply, and it will be able to drain as much current as it needs. And then I can add another load. Okay, I can keep adding as many loads as I want, as long as I have enough energy available for all the loads. Okay, because it's going to drain a lot. So you see now you have 2 light bulbs, very happy. They both get the same voltage, and they drain as much current as they want according to their resistance. I can add a third one here, so I'm going to add another one here. So I have a circuit in parallel, so the 3 of them are very happy. And it doesn't matter where I'm going to measure the voltage will be the same across each load. 2.7, that's going to be about same, 2.7, 2.7. All of them will have the same voltage. Okay, now if one of them dies, or if I put a switch and I turn the switch off, or I open the switch, you see this one will stop working, but the other one will keep working. Okay, so for the voltage it will be the same. For the current, if you have 3 amps or 5 amps drain from the power supply, then the sum of the current has to be 5. Okay, so you have 2 for this one, maybe you have 3 for that one, so then nothing is left for this one. But this one will take some current, so if you have 5, you can do 3 here, and then 1 here and 1 there. So the current depends on the resistance. Okay, so you drain more current from the battery. Okay, you can measure how much current we are draining. You can take your device here. You go to amps. Okay, amps here. Okay. I'm gonna I'm gonna close that, and you have about 0.8 amps, so 780 milliamps. Okay, before we had in series we were in about 0.2, so you're draining more current.